Hello everyone. Now we are going to discuss about the dihydric alcohols, their synthesis and reactions. Before going to that dihydric alcohols, what do you mean by the term dihydric alcohols? See, they are the compounds which contain two hydroxyl groups. They are called as diols or dihydric alcohols. Normally, these diols having this hydroxyl group bonded to the same carbon atom are unstable. See, if two hydroxyl groups are present in the same carbon atom, they are unstable, but they will undergo spontaneous decomposition to yield a carbonyl compound. So here we will find that one. Here the carbon that has been attached to two hydroxyl groups. So same carbon atom is having two hydroxyl groups. So they will tend to produce a carbonyl compound. One ketone will be formed with the elimination of water molecule. So the diols having the hydroxyl groups, they are bonded to different carbon atoms. They will be stable. Here we will find the examples. Here one hydroxyl group is attached to one carbon atom, and another one hydroxyl will be attached to another carbon atom. One and second position hydroxyl group is attached here. So this another one example, the hydroxyl group is attached to first carbon atom, and here the hydroxyl group is attached to the third carbon atom. So this is about the dihydric alcohols or diols. We will see the synthesis of this dihydric alcohols. Here we are taking the ethylene. The ethylene and treatment with hydrogen peroxide H2O plus oxygen in cold potassium permanganate. What will happen? The hydroxy group will be attached to that carbon atom CH2OH, CH2OH. So ethylene and treatment with water and oxygen in presence of cold potassium permanganate, ethylene glycol will be formed. So this is one of the examples. This ethylene glycol is one of the example for dihydric alcohol. This next method will be by hydrolysis of ethylene oxide. We will find the structure of ethylene oxide CH2O, CH2, which on hydrolysis, that is addition of water molecule at a temperature of 60 degrees Celsius, it will be converted into ethylene glycol, that is CH2OH, CH2OH will be formed. So ethylene oxide and addition of water molecule at a temperature of 60 degrees Celsius, ethylene glycol will be formed. Then ethylene by passing in hypochlorous acid. Here you will find the molecular formula of hypochlorous acid, that is HOCl, CH2, double bond CH2, and treatment with HOCl, it will be converted into chloroethanol, that is CH2OH, CH2Cl will be formed, which on further treatment with water molecule, it will be converted or sodium hydroxide, it will be converted into sodium chloride and carbon dioxide. So it will give the compound ethylene glycol, CH2OH, CH2OH, with the elimination of sodium chloride and carbon dioxide will be formed. Next one will be the reactions of this dihydric alcohol, CH2OH, CH2OH, and treatment with the sodium metal. So monoalkoxide will be formed. Here you will find the structure of this CH2ONA. Half molecule of hydrogen will be eliminated. Half H2 will be eliminated. This monoalkoxide and further treatment with the sodium at a temperature of 160 degrees Celsius, it will give the compound dialkoxide. Here already one molecule of sodium has been attached. So one more sodium will be added here. So it will give the dialkoxide with the elimination of H2. One hydrogen will be eliminated. So this ethylene glycol and treatment with the sodium, it will give monoalkoxide, and further treatment with the sodium at a temperature of 160 degrees Celsius, it will give dialkoxide. So next reaction will be phosphorus bromide. So ethylene glycol CH2OH, CH2OH, plus 2PBr3, that is phosphorus bromide. What will happen? Ethylene dibromide will be formed. Here CH2Br will be formed with the elimination of phosphoric acid 2H3PO4 will be eliminated. The next reaction will be reaction with the aldehyde, that is CH2OH, CH2OH. This ethylene glycol and treatment with the aldehyde such as acetaldehyde, CH3CHO, it will give the cyclic acetal will be formed. CH2O, CH2O, CH3CH will be formed. This is the structure of cyclic acetal. These are all the various reactions of this dihydric alcohol. I hope you could understand the synthesis and reactions of this dihydric alcohol. Thank you.